Hello. Please feel free to watch this video again or pause it so that you can write down the notes. Today we're going to be talking about quadratic functions not in vertex form but in standard form. And standard form of a quadratic function is y equals a number a times x squared plus another number b times x plus another number c. We call that the constant. This is just another way of writing the equation that will graph a parabola. Now, even in this form, the parabola still has the axis of symmetry and the vertex. And remember, when we're finding the axis of symmetry and the vertex is either the highest or lowest point on the graph, and this would be our vertex. And the axis of symmetry is the imaginary line that cuts our parabola exactly in half and allows us to fold it so that each part will match up. So, even in this standard form of a quadratic function, we can still find the vertex and the axis of symmetry. Now, when we find these two things, we want to be accurate and as accurate as possible. So, we have a formula that will find us exactly the place where the axis of symmetry exists. And the formula for the axis of symmetry is x equals negative b over 2a. Now, in order to do this, we need to be able to identify which numbers in our equation here are the a, the b, and the c. The nice thing is, the a is always attached to the x squared, the b is attached to the x, and the c is by itself. If your equation is missing any of these, then you don't have an a or a b or a c, or it's 0. So, in this equation, since the 2 is attached to the x squared, that's our a. The 3 is the b because it's attached to the x, and the 6 is the c. Or rather, negative 6, because it says minus 6. We can put that as plus negative. So this is c, negative 6. So we go to our little formula for the axis of symmetry, which is negative b over 2a. And then here's our b, that's 3. So our axis of symmetry is going to be x equals negative 3, because that's the b, over, and then when it says 2a, that's 2 multiplied by the a. When they're next to each other, it means multiply. So 2 times, in this case, the a is 2. 2 times 2. So, our axis of symmetry is at negative 3 over, well, 2 times 2 is 4, negative 3 fourths. Or, if you'd like to write it as a decimal, negative 0.75. Now, this also gives us the ability to find the vertex of the parabola. And when we find the vertex of the parabola, this is a great place to use your graphing calculator because you can type things exactly into the y equals and the equation will show up and graph it for you. So let's try and find the vertex of this function. The same function that we were working with before. Now I'm going to go to my graphing calculator and I'll switch the screen to the graphing calculator so you can see what I'm typing. And in my graphing calculator, I'm going to turn it on and press the y equals and clear anything out of the y equals that's already in there. And I'm going to type the equation, which was 2x squared plus 3x minus 6. And I'm going to type that in my y equals and take a look at the graph of the parabola that I should see. Here we go. Now, I know, based on my knowledge of the vertex and the axis of symmetry, that the vertex and the axis of symmetry, here's the vertex, the axis of symmetry is right here. The vertex and the axis of symmetry have the same x value. So if our axis of symmetry has an x value of negative 0.75, then our vertex also has an x value when we list the point as x equals negative 0.75. That's my x. All we need to use the graphing calculator to do is to find the y that corresponds with the x and the vertex. Now that's very easy in your graphing calculator because if you press the trace button, T-R-A-C-E, right next to the graph button, trace, and then you go ahead and type in negative 0.75 or whatever value you get for your axis of symmetry, and then press enter, it automatically moves the cursor directly to the vertex point, which right here is at negative 0.75, and it tells you exactly where the y value that corresponds with it is at. In this case, the y value that corresponds with negative 0.75 is at negative 7.125. So effectively, in one small formula, which was x equals negative b over 2a, we found the axis of symmetry right here, and we found the vertex. And we were very accurate. There was no guessing involved. This is the actual axis of symmetry and the actual vertex. There's no rounding. So please feel free to watch this video again to help you learn how to find the axis of symmetry and the vertex.